Hi, and welcome to my video about thinking proportionally. The first one that we're going to take a look at is directly proportional. And so here's what the graph looks like. The basic formula would be y is equal to kx, where here is the x part and here is y. And what is k? Yes, indeed, k would be the slope of that line. So just very quickly then, here's a couple examples. If x gets tripled, then what is going to happen to y? Well, y will also be tripled, or I'll just say multiplied by 3. If x is multiplied by a half, then y is multiplied by a half. It's very simple. Whatever x is multiplied by, y is multiplied by. Looking at my example here, it says John is paid $10 per hour. Show how the relationship between, I changed this to time, and the units are going to be hours. Okay, so it's here I could also change this then. This could be time. And over here, this would be wages. So it would be the same idea. Show how this is directly proportional. Well, here's how my formula would look. The wages would be 10, I'll put the units in here, $10 per hour multiplied by t, which is the number of hours. So that looks just like y is equal to kx. So you can see the corresponding parts where the slope here is 10. Another way I could do this is to say, hey, what if I did a table of values where I said, here's the time that they're working in hours. For example, if they work 0 hours, what's the wage that they will get? And the units for that will be in dollars. Well, they would get 0. They would get nada, nothing. What if they said 1 hour? Then they would get $10. 2 hours, they would get 20. I'll do a couple more here. They would get $40. Okay, so let's go back and say, okay, if the amount of hours that we're working is tripled, in other words, if this value gets multiplied by 3, here's an example of x gets multiplied by 3. So I could say if this value is multiplied by 3, you can see how it works. Then this multiplied by 3. Okay, how about could I do a half? Well, I'll just erase this stuff here. Well, if the person was working 4 and then they got their number of hours cut in half, then their wage would also be multiplied by half. So here I've shown how this relationship is directly proportional. Let's take a look at our second one here, inversely proportional. So this one, the basic idea would be y is equal to k over x. Sometimes people write y is equal to k multiplied by 1 over x, but that is a little bit more writing, so I'm going to stick with the first one. In this case, whatever x is multiplied by, y is multiplied by the reciprocal. So in this case, if x is tripled, then y is going to be multiplied by the reciprocal of 3, which is 1 over 3. If x is multiplied by a half, then y is going to get multiplied by the reciprocal of half, which is 2. Okay, so if this is x and this is y, how did we find this relationship? Well, here I'll just move this out of the way. What we did in our course is that we would say, well, we need to graph, instead of y versus x, we graphed y versus 1 over x, and then we got a straight line. And we said y is equal to k multiplied by 1 over x. Or another way of writing is y is equal to k over x. Let's see about our example here. It says, if one painter takes 10 hours to paint a house, show how the relationship between the number of painters and the time to paint the house is inversely proportional. Let me just think here for a second here. If I said, okay, so the number of painters is n, and the time is the number of hours. So one painter, it takes 10 hours. If you have 2 people to do the same job, it's going to be 5 hours. If you have 4 people to do the job, it'll be 2.5 hours. If you have 5 people, 2. If you have 10 people, 1. I hope that makes sense. So here I could say if t is the number of hours, it's going to be equal to 10 multiplied by 1 over n, or another way of writing it is t is equal to 10 over n. So you can see how this relationship looks just like my y is equal to k over x, right? So I could go back over here and I could show that here. This would be my n, my number of painters, and this is t, the time. And I would get this kind of a graph. Let's just see if this looks similar. If I take a look at this, is there an example where x got tripled? Not an easy one to find. Well, how about this one? How about when this one between here and here, n got multiplied times 5, and from here to here, time got multiplied by 1/5. So you see the example. Okay, so if you have inversely proportional, whatever x gets multiplied by, y gets multiplied by the reciprocal. And you can see kind of how it works. If this x is in the denominator, if I'm going to be multiplying this thing because it's in the denominator, then y is going to get multiplied by the reciprocal. It's like if I compare 1 over 2 versus 1 over 4. I've multiplied my denominator times 2, and the overall value is now worth half as much. So if you pay attention, you say, okay, in this case, x is in the numerator. Whatever x gets multiplied by, y gets multiplied. Here, x is in the denominator. Whatever x is multiplied by, y gets multiplied by the reciprocal. Okay, taking a look at C. Oh, this is a pretty straightforward one. No relationship. So if you have something like this, x versus y, thinking about now my y is equal to kx plus b. Remember that this k here means the slope. And if I have something like this slope here is equal to 0. So this would be the same thing as y is equal to 0 times x is 0. So this would be just y is equal to b, where b is the y-intercept. So if x is tripled or multiplied by 3, then y stays the same. If x is multiplied by half, then y is the same. There is no relationship. It doesn't matter what you do with x, y is going to stay the same. Here's an example. There's no relationship between the number of glasses of water Mr. Spicer drinks, G, with the number of days in 2017. So the number of days in 2017 is equal to 365. So if I do a comparison, if G is the number of glasses that Mr. Spicer drinks and D is the number of days in a year, if I drink 1 glass, there is 365 days. If I drink 2 glasses of water, there is 365 days. It doesn't matter what I put in here, it's always going to be 365. There's no relationship between the number of glasses of water that I drink in a day or at all and the number of days that will be in this year. All right, here's a direct square proportion. So if I put this here and this here, you'll recall the way that we linearized it is we said, hey, I'm going to say y is proportional to x squared, and then we often got a straight line. So the relationship is y is equal to kx squared. So in this case, whatever x gets multiplied by, let's say if I multiply it times 2, then the new value of x will be twice as much, which will, that 2 gets squared, so this 4, so if I say this times 2, then this here will get multiplied times 2 squared. So if I increase x a little bit, y really changes. If I multiply x times 3, then y is going to get multiplied by 9, which is 3 squared is 9. If x is multiplied by half, then y gets multiplied by 1/4. See if I can take a look at this example. It says, show how the area of a square is directly proportional to the length of the side of the square. Okay, well, if I make a table here and I say that the side, or the length of the side, L, is that what I said? The length of the side, say in meters, and this would be the area in meters squared. Well, if the length of each side was 1, the area would be 1. If the length is 2, the area would be, right, 2 times 2, this area inside would be 4 square meters, 3 would be 9, and so on. So if I try to do a formula here, A is going to be equal to L squared. To review here then, if I say, hey, if I multiply this times 3, I'm multiplying this length times 3, look what happens to the area. It gets multiplied times 9. Okay, if I were to multiply the length times a half, then the area gets multiplied by a quarter. Here are some practice questions. I would like you to give those a try, and then as a way to study for a test or a quiz, and then you can come and show me your answers and see how you did. All right, thank you very much.